Hello and welcome to Poor Man's Electronics Bench. In this episode I am going to cover the inspection, disassembly, cleaning, and restoral of a Eico Model 1140 resistance capacitance substitution box. I am trying to cover some devices that, although are dated, are still useful to the people that may be interested in using them for vintage electronics repair and restoral work. This particular item does not have much internet coverage right now, so I thought it would be worthwhile to add to the world of online information for others that may have interested in obtaining one to restore and use. These were available some 50 plus years ago, in kit and factory assembled form as well, but they now have components that are most likely too far out of tolerance to be useful unless a good inspection and overhaul is performed. This video series will cover an overview, inspection, parts value testing, disassembly, cleaning, restoral of the front panel graphics, and finish and display the final product. I hope you enjoy the video and the information. Hello and welcome to the next episode of Poor Man's Electronics Bench. In this episode I am going to go over the inspection of and restoral of a new to me auction purchase of a Eico Model 1140 Series-Parallel RC combination box. This item was available probably about 50, 60 years ago from Eico as a factory and or a kit. I do have a factory... No, I take that back. I do have a kit manual available for assembly on this, but it also has the operation instructions. I figure it's a pretty practical box they have. This is one item I'd like to be able to have functioning properly and use to do some restoral work on other equipment, because there's going to be times where I'm going to need to substitute some resistance values and to check the functioning of things. The nice part about this is this also does have functions for putting resistance and capacitors in line, in series, and also in parallel on the output. It has, I'll go over some of the functionality and the switches here. On the top, I'll zoom in a little bit. On the top left is the low range resistance switches. So it has a bunch of positions on that one. It has a just single pole, single throw slide switch that switches from low to high, so you have resistance values all the way up to 10 meg on that. And on the bottom portion, on the lower left, it has capacitor values from 0001 all the way up to 0.022. And then you have a selector switch for your functions. It has a short circuit if you want to test the actual leads or just make it a short circuit on the output. Parallel resistance capacitance, resistors, which allows you to use the rotary selectors and also switch ranges. It has a capacitor switch that puts the capacitors on there. Excuse me. It has a series RC switch which puts the resistance in series with the capacitance. And then the last selection is to open the leads. And then this particular box, for some reason, this isn't factory, somebody decided to put a female banana jack in here. I did some inspection on it. I've opened up this box already, so there's no real big surprises going on. I also did a little work on the inside of it as far as cleanup. I could go over some more of that though. So opening up things, the box is just a regular Bakelite box. It's in reasonably good shape with no huge cracks or chunks out of it. I'm not really interested in restoring this to museum quality as much as making it functional and having it work within tolerance for all the components inside of it. Now in this instance, the front panel does need a little cleanup work to it. You can see it's got a little haze to it. The nice part about Eico equipment is, I don't know if have any or ever run across any, a lot of it has the the graphics on it stamped into the aluminum panel. And the nice part about that is it allows you to take the panel and give it a very light sanding, a polish, or apply some other type of look to whatever you want to do as far as making the panel shiny, getting rid of any corrosion on it. It probably had a anodized aluminum finish with no clear coat on it or anything, but over the years, you have to keep in mind this item's probably about as old as, at least as old as me, about 60 years old or so. It's had some wear and tear. This one's terrible, but it allows you to clean things off and go back over it with some sort of ink or paint and let that settle in to the embossed graphics. Wipe it down, and you should be able to take something like this and just set black paint or black ink into it and have it very legible. And one thing I did notice about Eico stuff, though, is this red paint or ink, whatever's in there, that is susceptible to smudging fairly easily if you use a fairly aggressive cleaner like acetone or something like that. I think about the best cleaner I've seen that doesn't really smudge the red ink might be isopropyl alcohol, but that use it sparingly and be prepared to possibly take some of that ink off of there. I'm going to go look at the back side of this guy. I did go through and I've already did a good inspection of and cleaned all these and cleaned the rotary switches. The one thing I always like to pay close attention to is all of these little contacts, these little spring contacts on rotary switches like this, because I have seen instances where these contacts have been bent or damaged or corroded, these guys here, to the point where they won't make a good connection to the rotary switch tab there. The round middle portion is all a permanent contact to the common, which comes off the side over here on this switch, but it's a good thing before you even rotate a switch like this, when you first get the device and you have any type of rotary switches, to get into it and take a very good look at any type of rotary or moving contact you might have to make sure they aren't bent or damaged, because there's a chance that you can get in there and bend it straight, make it into some sort of workable position without doing any further damage by just blindly rotating it just to go, oh, let me see if this knob works. Well, you might just end up doing damage to it. So you're better off just resisting the urge to just twiddle knobs and play with things until you can get it open and take a very good inspection of it. And in this case, all of these are in really good shape. I did go through and cleaned them up with some contact cleaner really well. I sprayed some Deoxit D5 on them. Got soaked a little bit. You can maybe see a little bit of the residue from the red lubricant and the Deoxit a little bit here and there, but that's not what might be considered embalmed. But it does have a little bit of a residue, but that's what that Deoxit D5 is supposed to do. It's supposed to clean things and then leave a very light residue of lubrication on it. And a lot of times these, like in this case here, this could probably use a little better cleaning. I'm probably going to go over it a little better with just a swab and some cleaner. But there's one place you got to pay attention to also. There's a mechanical detent on this, and I'm going to go over it a little later. What happens is there's usually some grease in this area, some grease and dirt, and the grease is as old as the unit. It's 60 years old. If it's petroleum based, it's more likely than not going to be hardened and crusty. And I'm planning to go through, I'll cover it in the video, but I'm going to go through, I'm going to take everything off of the panel here so I can get access to it a little better. Go through there with some acetone, clean all that up, and then re-lubricate it. And the switch for the high and low resistance is just right there. It's just a single pull, single throw, nothing too exciting about it. It's probably even could be replaced if damaged by something that's still available. So it's basically, this is just the construction. It's just a couple of resistor arrays that they configured with one common ring for one polarity, bridged it over, another common ring for that polarity, and then wired both of those together into the switch. For some reason, the person that put the female banana jack on there decided that they wanted to have that as a full-time connection. Maybe they wanted to use, you can't really use two resistance values at once that I can think of, or no, I don't think so, because it's the way this is wired. All the other pull on the resistors is accessible only through the slide switch, so not sure why it's there, but it's there, so we're just going to leave it. It's not hurting anything. And then there's some old capacitors. General instrument capacitors. So let's going through things. I've checked the values on all these already. I've come to the conclusion that I'm only going to replace what's out of tolerance, and everything on the resistors is all silver banded for the tolerance, so that's at 10%. The capacitors are marked with a plus minus 10% on them, so we're going to go with that as well for replacements. And there's nothing too complicated, earth-shattering, or anything about this particular device, except for the fact that it's nice to have one available to you if you're in need of putting a resistor or capacitor in circuit without having to go into a parts bin or something. You can, an item like this, it's not like a decade box, or it can let you vary things by a ohm basis, but it will let you just take an assortment and adjustment range. A lot of times, most stuff like this is a lot more useful on older vintage equipment, tube style, because the values that are in most of the circuits and that aren't critical down to extremely low tolerances a lot of times, unless you get into the radio frequency oscillator circuits, which this doesn't really cover much of. But as far as bypass or blocking capacitors, the values are useful. They're also a higher voltage range to be able to use it. These are 400 volt capacitors as well. So what I'm planning to do is just go through this, check my values as I go along, go through a little bit of the process of how I'm doing that, maybe with a few other things to add as far as Timesaver and being able to figure stuff out quicker, and then go through and actually do the work on it. So stay tuned, and we will cover that on the next part. I'm going to take a quick minute to put an insert in and go over the ad that I found for this in an old Eico catalog that somebody was nice enough to load online. It's listed as an Eico 1140 series / parallel RC combination box. A value combination of the Eico model 1100 resistor box and the Eico model 1120 capacitor box. Open circuit and short circuit positions are also provided. Kit and wired. It does not show a price for it in this particular ad catalog or flyer, but this is the unit right here, and if you notice, there's only 2 binding posts on it. So whatever was added down in the lower position was done by somebody just interested to get that tap off the one lead on the resistors. I don't know why they did it. Maybe it was just something to eliminate having to use that rotary switch that left the resistance in full time. But if I figure out a useful purpose for it, I'll use it later. But I'm not going to try to remove that banana jack and fill that hole. That would be more effort than it's worth. It doesn't look like it's out of place, so it'll just stay in place as it is. And now I'm going to go over the testing of some of the components on here. For resistance, I'm going to use a meter that I like. It's a older Greenlee DM860 digital multimeter. The one thing I like about it is it is able to measure resistance fairly quick. This is one of the faster meters as far as coming up with the value on it. And in this case, I'm going to use the delta to zero it out, even though it's nothing really on a critical value on here. But we're going to just do that, and I'm going to start out with connecting for my two binding posts on here and go through my ohms measurements. I'm starting out. These older Allen Bradley resistors, they're carbon resistors, but they're still not all in great shape. They tend to drift high over time and out of tolerance. And what I've done is I've made up a spreadsheet. I'm going to show you that a little bit to keep track of everything. I've got that in another Suncor 75 model Handy 75 box I'm working on for information on here. Made up a spreadsheet with the values on it where I can keep track of what's in tolerance, what is out of tolerance, and then also I made a calculator to figure out the tolerance on percentages on things. I have the first resistor first value is a 15 ohm, and keep in mind these are all 10%, and it's coming up as a 16.53. And I made up a spreadsheet with some calculator functions on some cells. It's something that's carried over from things I learned at work. To kind of expedite processes instead of sitting there and trying to do math in my head. I've already done too much of that. My brain's burned out, so I try to just do things that do certain functions for me so I don't have to think too much. So in an instance like this, we've got a 15 ohm value, and I'm going to put that in there, and I have the values figured out for tolerances of 1%, 5%, and 10%. In this case, we're going to be using the 10%, so I have that highlighted. There's a simple math values you can put in cells for spreadsheets. I don't know how many of you have ever dealt with them or not. Right now I'm using Google Sheets. Microsoft Excel is another main product that most people might be familiar with in the business environment. Open Office is another one. It allows you to open, create, modify just about everything that Microsoft Excel does, but that one is an open source software that is free as well. It's it's a pretty big program, but they upgrade it now and then. There's no ads, there's no fees for it, and it's fairly functional. Each one of the softwares seems to have its own peculiarities and formulas as far as the characters you use to do math with. In the case of Google Sheets, I can show you here. There's a functions value here. This has all of the little characters you might want to use to do certain functions on it. If you go up to your functions thing there and go into math, anything that you click on here down to, if you want to do something to the power of, roundup, sequence, series, sum if, all, it's a pretty valuable group of functions, and all of this is for free within Google if you get to the Google Sheets part of it. So in this case here, in this one cell, I'd like to take the value of it, which is cell G18, and then for a 10% tolerance, I'm going to multiply that value, which is just a star, no spaces, and multiply that value by 1.1 for my plus 10%. For minus 10%, I would multiply it by 0.9. So putting 15 ohms in here, it tells me that my plus tolerance is going to be 16.5 ohms, and if you look at my DMM, it shows 16.54. So that is just outside of tolerance on here. So then what I've done is I've taken out of these, as I've colored these cells as I need to, as far as to see if they are out of tolerance or not. So anything I have in gold right here, you can just highlight a cell, go up to your fill color, and change it to whatever color you want. In this case, I'm using gold for things that I need to order components on. And then another thing I do, I don't know if you've seen one little video I have for keeping track of components that might need to be replaced, and to be able to go back and keep track of the fact that you actually worked on it or not. In this case, I've got this is a chartreuse fluorescent marker. These are available. Got this one on Amazon. So in this case, I have this one resistor here I'm set to. You can see the tab for that connection is set to that resistor, and it is out of tolerance, so I'm going to mark it with a little bit of fluorescent chartreuse ink. Now what that's going to do for me is it's going to tell me that that particular component needs to be replaced, and also I can keep track of whether I replaced it or not. And one way to do that out of a final inspection, not totally dark in this room, but I chose that fluorescent chartreuse ink for a reason, because you can take a small ultraviolet light source, any light source, and go through it, and it turns into an instant eye catcher. It's more visible and where I'm sitting from here, but it looks like a brightly illuminated hand on a old clock that they used to paint with radium paint. It definitely, my eye is definitely like drawn to that and saying, hey, you forgot that part. So it just kind of gives me two levels of being able to track whether whether a part needs to be replaced, and B, whether I've replaced it or not. So it just gives me another chance of going through things. So I have to go through and go up to the next few values here. Got a 22 ohm resistor value that is measuring out as 23.2. So what I'll do is I'll go back to my spreadsheet, enter 22. Oops, not 220. It tells me that my maximum tolerance value for 10% should be 24.2, so that one's acceptable. So we're going to, I've got that one marked as green as not needing any attention. Switch up to 33 ohms. That one is obviously wrong. It is giving me a reading of 71 ohms. And it doesn't seem like the switch contact is bad. It's definitely there. I probably could just jumper that resistor to check the switch contact and make sure that there's not a fault in the switch, but I'm doubting there is. Nope, that goes to a dead short when I jumper it. So you're going to mark this resistor as bad as well. I don't really care if I get the chartreuse ink on the other values because it's going bye-bye. So that's part of my process, just for going through and evaluating what needs to be replaced or not. A 47 comes out as a 51.8, so we're going to go 47 and On my spreadsheet it shows a 51.7 is my acceptable plus 10%. So that one's also on the high end. If something's really close, I might just go through and change it just because knowing it's going to drift up pretty soon. You know, it took them 60 years to get the drift out of value this high, but it's just not going to get any better over time. So if it's close to that 10% top of the range, I'll probably end up changing it out. So 68 comes up as a 77. So we're going to put 68 into the formula box, and the tolerance on that and plus 10% is a 74.8. So that's another one. So just going to keep marking and marking, and the amount of fluorescent chartreuse paint will get more and more, but as I go through and change it out, it'll get less and less to the point where I do a final inspection. I'll shine that ultraviolet light in there, and I should not see any fluorescent chartreuse paint glowing back at me. So I am going to continue with that process and then move on to the next part of disassembling the panel and cleaning up all the mechanical indents on the switches and lubricating the knob shafts on them. That's going to be my next part. Hello, and I'm back online here. I ended up going through and checking resistors and capacitors, and I don't know if you can see it, but I found a bunch. I can maybe show it to you a little better with the ultraviolet. There was a lot of the capacitors, since they were a old foil type. You can probably see it a little bit, but there's a good bunch of stuff to replace here. Almost all the capacitors except for some low value postage stamp ones, those are actually fine. And bunches and bunches of resistors. So as I go through them, I'll eliminate the resistors and the fluorescent paint. So on my final inspection, not only that, but my newer resistors are going to look like a newer style, being probably metal film on a lot of them. But there was a bunch of stuff to replace, so I documented all of that. Put some lighting back on here, and what I'm going to do now is disassemble that front panel parts to clean the switch positions up a little bit better. I'm going to, first off, like I said, I've got this edition of a male banana jack. It's not a stock part for some reason. That person just took it and decided to wire it to the connections for the returns on both rings. So I'm going to just use a good old Weller. I'm not even sure what model number this was. This was an Expert at the time. had this thing in the family. Yeah, looks like it's still got the model 8200 number on there. So it is a these things are tanks. All they are is basically a 2-winding step-down transformer that puts a low voltage high current onto a piece of copper, which is your soldering tip. And nice part about it is they heat up very fast, so you don't have to take any bench time for waiting for a soldering iron to warm up to the right temperature. And that's the only electrical connection I have to disconnect off of this panel. So I'll let that iron cool off a little bit as I'm doing things here and kind of go through. The knobs they're all the same. They look like a Bakelite plastic, and they all have a set screw on the back. I'd imagine all the shafts are going to have a flat on them. Trick here is to get a screwdriver that is sized as closely to your screw slot as you can. If you get something that's too big, you're going to tear up the Bakelite trying to get to it. Too small, and you have a instance of possibly tearing up your little screw and or the tip on your screwdriver. So you're best off just getting something that fits as closely as possible, and hopefully something that has a hard enough steel where it won't start twisting the tip, as some stuff that's made nowadays is not up to a very great quality. This is an old Craftsman, so I'm seeing there's a bit of corrosion on all of the flat washers behind there, as well as a little bit of oxidation on the shafts itself. The shafts are rounded, but this one has two flats on it, which is interesting. I'll know which flat to use. All of them are like that. I'll know which flat to use because of the mark from the set screw left on it. I'm removing it. And all four loosened up and got removed without incident. And now I guess I'll go for the front panel screws and try to get me a little bit larger screwdriver blade to go into that one. And hopefully I can just hold the nut on the backside with my finger, and yeah. Okay, that's one. That one's a little bit tricky. Oh, it looks like, almost looks like there was a solder glob on the backside of that screw. I don't know if that was a purposely executed maneuver or just something that happened, but it's not very well soldered if it was, because it's coming loose. God bless magnetic tip screwdrivers and magnetic tools in general, because they've grabbed all my hardware. So get the hardware in a spot on this mat where it won't go walking off the bench. Then thankfully the connections for the two 5-way binding posts are nuts on the back side of this. I believe I have a small nut driver set somewhere, if I can find it. Let me try something here. Yep, 1/4 inch. Very handy to have something with the 1/4 inch magnetic bits, because that 1/4 inch comes in handy for a lot of other hardware as well. Like I said, at this point I am interested in disassembling this because I would like to clean up. I can clean up the panel when this is off also, but I need to get some lubricant in the shafts and then clean up the spring detent assemblies on all these switches. So on these guys you can either go, if you've got a larger nut driver or a open end wrench of some size, I'm going to use a hopefully well adjustable. Thankfully it's cooperating. Have to kind of hold the whole switch configuration on the back side here to keep it from rotating. I was putting a little torque on it. There we go. This is a smaller selector switch. Haven't had a little torque to it. And this guy here. There we go. All of these should be about hand tight. I think I have some lock washers sized for these shafts. I might replace the rusty metal ones with. They look like they had a plating on them at one time, but 60-year-old equipment and some moisture, and you have what you have. And there we have it. Lock washers on the back side. Try to pop those off. Some of them got stuck to the switches. And there's only three little items to take off the back of this guy, and then I will, part of this restoration, I'm going to pursue cleaning this panel up a little bit, repainting the markings on it, and then possibly putting something like a clear coat epoxy on it to preserve it. So now we have our switch assemblies, and they are in various states of having some corrosion on them. Not sure what cleaner is going to work best on there. I might just spray a regular electrical contact cleaner into a rag and wipe some of that stuff on the exterior off. Maybe a light coating of WD-40 afterwards wouldn't hurt. This wiring has some sort of residue on it. Doesn't look like this was ever submerged or directly exposed to moisture, but it's definitely has some internal corrosion issues. Mild, thankfully. And the switch here has some, I think I already sprayed this with DX, but I didn't clean the surface part up of it well. Well, what I do have is a bunch of little cleaning Q-tips. Come in very handy for this, and some acetone. So this is one. Acetone's a nice cleaner, but you have to be aware of the fact that it is flammable. So if you are going to play with it, you don't want to be in an area that has any type of exposed flame, pilot light nearby, anything that the fumes might get to, and have that flame cause a source of ignition. I'll try to just go through and clean up the front part of this switch plate here. It's got a little dirt on it. Doesn't appear to want to get much cleaner, so that's corrosion's in there. So in this case here, these switches have a larger contact area. Now I'm going to have to put a knob back on each one of these as I go in order to rotate them and clean them. Got some little pieces of paper towel on there that don't belong there. Those shop towels are supposed to be fairly lint-free, but I guess in this case they're not. So as you're rotating this, it has a cutout area in that spring switch that lets you get good access to all of those detents. Oh, there goes the knot. So soak a little more acetone on the Q-tip and go through and clean off the part that I have exposed as well as possible. Rotate this in its opposite position there. Kind of nice to be able to take something off a panel like this and not have to do a major disassembly. Unsolder all the wires. Hopefully if you find access to one of these, you'll get it in a fairly similar condition where it doesn't need a world of attention to it, but some minor cleaning. So I believe that was the one I got already, so this one looks like it has accessible area. I may have cleaned these off already or something. I don't think I did though. I didn't take this apart, so it doesn't have. They don't have a terrible amount of grease on them. Some older switches like this, I have found that there was some old, like a lubriplate style grease or something on them that was built up. Another spot-to-spot wire there. Get that out of the way. This switch I might have came through and lubricated already. I noticed that there's some residue here. It's the type of grease that I use. It's the dielectric grease. I might have done it before I took the panel apart, but I'll go through that with you here as far as lubricating it. I've got an oil to lubricate the shafts with as well. I use something like this. There's a lubricant called Tri-Flow. I've got it in a little needle bottle. It's just been around for a while. It has a suspension of Teflon in the oil, Teflon particles, and that's all the white buildup on the inside of the bottle. I had a lot more grease on it, but there's some mixed in with the oil there. But it will, even once it dries out, it's going to leave a residue of Teflon lubricant behind. And the trick is to actually get it. I don't have a lot in this bottle, so the trick is to get it all the way down where the needle will let me dispense it. There we go. Got a couple drops of it going on there. That'll help lubricate the shafts on these switches. It's nice to see that these didn't have any corrosion damage to them. I had another older Syncor device like this where it was just a capacitor substitution box, and these things were just, the switch contacts were just so corroded from the capacitor electrolyte that leaked out, and it just basically made the switches unusable. Or the one switch, I should say. Whoa, hold on. Bump the camera stand there. Hold on. That takes care of lubricating the shafts on these guys, and now we're going to go to lubricating the detent positions. And my grease for choice on this, it's not necessarily what is used as a lubricant, more of a insulating and isolating grease is an old tube of Permatex dielectric. It's a silicone grease, and it's, the nice part about it is it does afford a lubricating property, and for one, and number two, it does not dry out. So it will not leave a residue over time. So I'm just going to take a smaller swab and dispense myself some grease and smear it in where the detent tab is. And where is my, boy oh boy, hey, the knob got away from me here. I'll have to watch the video to see where it went, but in the meantime I'm just going to put another knob in here. I'm going to get that in a position where I can get to other spots on the detents on the switch. I kind of like using this for stuff like the switches. It's not going to cause any corrosion. It's not going to leave a residue. It's a dielectric grease by its own description, so it's not going to conduct electricity and just not going to dry up. So it's going to function for a very long time. One thing I would really like to do is get these little pieces of towel out of there. So I'm just going to repeat that for the other two switch assemblies, and going to consider what to do with my front panel. Also probably go through here with some more acetone and all these capacitors. Most of them are going bye-bye. I only found the largest one out of the bunch, and the 3 postage stamp micas were within tolerance. Everybody else is going to go bye-bye, along with a bunch of resistors marked, as you can see. So that's the work I have cut out for me still ahead, so we shall get on with that in the next part of the video. I am going to end this part of this episode here, as I need to order components, and I will return with the front panel refinishing and new component installation on a part 2. I thank you for viewing this video, and I hope you enjoyed the content in return for upcoming new features. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.